Hello again, everybody. This is Joseph. Continuing with Automotive Hondas. I made a few videos about the instrument panel in your car, and this is going to be a little more in depth what it's referring to. I pointed out one thing. Everything has to work on 12 volts. If your instrument panel does not light, that means you don't even have 12 volts. You can't even crank a couple of amps to make that. So don't even think about cranking your car or start a motor. So therefore, you have to have 12 volts. And I explained one thing. How do you find the 12 volts and interpret and understand schematics? Okay? First thing is, I said, always look for like a common bus line. If you look over here, there's a connection here, a connection here, a connection here. Wherever there was a connection, I didn't highlight it so you can see it clearer. A connection here, connection here, connection here, connection here, connection here, here. All these are connections. That means it's a common bus line. That means that's a 12 volt line. So whenever you're looking for a 12 volt line, you follow that, trace back, and sure enough, boom, it comes to this fuse. Now, as we said, everything needs 12 volts. The gauges in your car need 12 volts. The bulbs that light up when you first turn on the car need 12 volts, and the ground. We'll get that in a minute. Just like a bulb in the parking, your parking bulbs, your headlight bulbs have to find a path to ground. Same thing for these bulbs. So, if you want to understand how to interpret the diagram, okay, this diagram is 2 pages. You follow the line, and it tells you, in this instance, it tells you yellow, white, 2. So you follow the next page, yellow, white, 2. You want to follow this line. Let's continue to the next page. You go to blue, 1, blue, 1. You want to follow these lines. You see the numbers, 3, 3. White, blue. But don't always assume on the colors. Sometimes you have a couple of lines that are the same colors. Go for the numbers. 4 is to 4, 5 is to 5, 6 is to 6. That's how you know. So it's continued on the next page. Now, like we said, what are the reasons for the gauges? What are the reasons for these lights coming on? Now, we know engine coolant temperature gauge. That's to tell you the temperature of the engine. That goes, in this case, it goes through a thermistor. And that thermistor is a resistance that changes with temperature. The higher the temperature, the lower the resistance. That's why you see this little thing going through it. That means it's variable. It changes. It's not steady. Whatever that temperature is, you see it on the gauge. Whether it's digital, whether it's analog, you'll see it. Preferably, it should be in the middle, right? It's always in the middle. Like, even in the summertime, when you put the compressor on, it'll go up a little, but it should be roughly around that the midpoint. Next one, tachometer. Tachometer is based on revolutions per minute, RPM, telling you revolutions of the engines and all that. Therefore, if you look at it, you follow the line. If you want to follow where it's coming from, you go to the blue, and sure enough, you have this junction connector, which has a lot of connections to it. When you come over here to this one, it tells you RPM input, cruise control unit, or transmission control unit RPM. It gets the RPM from these locations. The cruise control unit, which is a module, and the transmission control module, which is another module. So it gets the RPM from that. And it gives you that on display on your gauge. Odometer is a little different. It tells you if you want to know how many miles from here, if you're taking a trip from here to Florida, right? You zero it out, and it tells you how many miles that trip was. a little different from the speed, a little different from the tachometer. That place also goes to the same location as this one. The transmission control modules. The fuel gauge, as you've guessed, right? This is the line for it. How much fuel you have, obviously, right? Where does that come from? A fuel gauge sending unit, a resistor in there. That's changing with fuel. So therefore, that indication is to you in a gauge. A dimming circuit. See over here, we don't have the line going to the next page. But the light is here. And if you want to find out where it goes to, the red-blue wire, then you have to find the cruise control system. So sometimes it's continued on another page or another system. SRS, which is for the seat belts, the restraining system. This is on another page. See? So if you want to find this one, you have to go to that system on a different page. Charging system. See this? For alternator. There is from B plus going here, going through the bulb, coming out the other side of the bulb. The current flow, right? This comes on first when you turn on the car. When the alternator starts working, the bulb goes out. It should go out. If there is a problem with it, you follow it. We go through 3 to 3. We come back over here. Come back over here. And we see it goes to the alternator through this connection. Therefore, if there's a problem with the alternator, you're going to get an indication on the bulb. Maintenance was something a little different. Maintenance for these Hondas. Light control over here. Then there's ignition input over here. There's two things that come in here. This is an input. Vehicle speed sensor, as you see over here. The vehicle speed sensor is over here. Cruise control and engine control system are an input. This is some form of maintenance reminder to tell you that maintenance has to be done for something. When that happens, the light comes on. It's almost like nowadays in the cars today, it tells you the time to change the oil. You ever see that oil change light that comes on? Probably the same system over here that you have to do maintenance is due in time. But it goes through this module. So you need a B plus over here, and you need the vehicle speed sensor over here, and the ground. And you need a battery input. And that reminder will tell you something has to be done. Some maintenance has to be done. Every 3,000 miles you change your oil, whatever. Well, nowadays, as you see, it tells you sometimes before that. Now, the brakes, over here, you see the brake system unit over here. If you follow it, that goes to the brake bulb check over here. And if you follow it up here, there's two paths you can take, the USA or Canada, whichever car you have. If you follow this one, you're going in here. It's the parking brake switch. It tells you if the parking brake switch is on. Number one. It also tells you the brake fluid level switch. As you see over here, the brake fluid level switch. So if the level is low, it'll tell you. It comes back, and the indicator is on. This is what it's telling you. Also, it's telling you the parking brake is on. Usually, if you're on top of the hill, you put the brake on. Now, something a little more interesting, low oil indicator. We follow this over here, follow this over here, follow this over here. There's a switch to ground. If you read what it says, engine oil pressure switch opens above 4.3 psi. If you notice when you first turn on your car, the oil pressure, which is in psi, there's a gauge for that, and sometimes it's around in the midpoint. It should be around 20 psi or something like that, depending. There's an oil pump that circulates the oil throughout all the galleries and all that. Now, it's good to check the oil, great, in the morning, and you check the oil when it's cold and all that, but you have to have pressure to circulate the oil. After all, oil that's sitting there and it's not being circulated is of no purpose. It's like your blood in your body that's not being circulated. Obviously, the heart pumps the blood. There's a purpose to that, right? Same thing over here. You have to pump the oil. Well, when you pump it, there's a pressure. It's telling you anything above 4.3 psi is acceptable, and this will open. Anything below 4.3 psi, this will ground it. What does that do? That tells you there's a problem, and this indicator light will go on. That's why there's low pressure. Okay? Understand? One more time. There's a certain amount of pressure that you need. It's not enough just to check the oil, if you have enough oil. You have to have that pressure. Anything below a certain amount, in this case 4.3, is a warning light to you. Anything above 4.3, it's good. This light is not connected then to ground, and it will not light. So in other words, it's acceptable for this vehicle anything above 4.3 psi. Again, now low fuel indicator over here. You go back up here, and obviously this goes to a thermistor. You see how it tells you this is a thermistor. That's again a resistor that changes with temperature. The resistance goes down usually. Where does the current flow? To ground. You see, the basic point I want to make here is when you come and you trace the wiring, you come over here, goes in one side of the thermistor, current goes out the other side. Is the current going to go here? No. You're not going to go from a thermistor to this. Other thing is, if you take this path, which I took, the black and white wire, it goes to ground. Current always takes the path of low resistance. This is low resistance, so the current goes here. Why do we need that? If you trace it back to indicate the light. When you have low fuel, there's a thermistor, a resistor, and as the resistor crosses bulb, the bulb lights. Okay? So therefore, that's how to figure out the instrument cluster in your vehicle. So the warning lights obviously go on to indicate some fault or malfunction. That's when you pay attention to it. If you want to see this one, malfunction indicator light, this is the engine control system, which goes to the computer that tells you maybe there's a code, you need a scanner, you have to find out the code, maybe there's a misfire or something. So anything, what's important, if you notice, some lights are in orange or yellow. Some lights are in red. The ones that are in red, the warning lights that are in red, like the seat belts or the parking brake, those are the important ones. That's why it's in red. Stop what you're doing. Take care of this. That's why it's in red. In other words, put on your seat belt. In other words, take out the parking brake. That's important, right? That's why it's in red. The other ones that are in orange or yellow means, or like it's check engine light comes in, I think yellow, means take care of it when you can. Not priority right now, but take care of it when you can. So you pay attention to the ones that are in red. Again, the seat belts, the parking brake, the sometimes the what do you call it? The for the restraint system. The modules for the restraint system, it's in red. Then you take care of those things. The ones that are on yellow, orange coded, those are not priority right now. All right, thanks for watching. Subscribe to my other channel, Joe Electronics Schematics, please. And see all transistor circuits for college students. And my other one, Automotive Electronic Schematics by Joseph. And please leave comments about these videos. Thank you.